For today's final video of 2020, we're going to talk about formalizing notation. So what does this mean? Well, let's look at our warm-up here. Sometimes mathematicians use notation called subscript. It looks like this, or something like this. A sub 1. So there are a few examples below of how subscripts might be used in context of visual patterns above. So these visual patterns are considered these math notations. I want you to try and guess what each mathematical statement means in words. So such as, sequence 17 means that there's 30 blocks. Something along those lines. So I want you to actually try this at first. Pause the video and see what you're thinking. Obviously our words will be a little bit different, but I want you to give it a shot. So now that you've written something there, we're going to look at these. So if this was, I'm going to count the blocks first. 1, 2, 3, 4, 5, 6, 7. If this was my first term in my sequence, there's 7 blocks. If this was term 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 blocks. Okay. And then term 3, I bet you can guess it, 2, 4, 6, 8, 10, 12, 13 blocks. So as you can see, there's a pattern here. 7 to 10 is 3, 10 to 13 is 3. So it's adding on 3 more blocks. So this A subset 1 is equal to 7. If I was going to write this in words, I would write something like this. The first term in my sequence is 7. For the second one here, it says A subset 2, A subset 2 equals 10. So I could say this is, this is the second term in my sequence, and it is 10. Or you could say the second term in my sequence is 10. And what do you think this A subset n, so any number, equals 4 plus 3n? Well, what you notice is that this 4, okay, remember we've been dealing with sequences where, yesterday it was the shrinking dollar where it was originally 66 inches in height, and each time we multiplied by 0.75. So this is going to be kind of the same thing. This 4 is actually what my term 0 is. Meaning if I don't add any blocks, my first term is going to be 4 blocks. So I could say something like this. The 4 in my equation or function is how many blocks I started with and the 3n is how many blocks it increases by. So if I went backwards to prove this right, if I wanted to know what my term 0 was for this equation, or these blocks up here, I can just subtract 3 from my 7 blocks. So basically 1, 2, 3, and I would have 4 blocks left. 1, 2, 3, 4. This is my original 4 blocks I started with. So if I was going to look at the bottom one here, this bottom one here looks a little bit funky, and it might be weird, but it's totally fine. So a subscript, we can also say a sub. So a sub n equals a subset n minus 1 plus 3. So this a sub n minus 1 is actually saying, hey, the previous term that we had before, you're going to add 3 to that. So if I have a sub 1 equals, I'm going to use the previous number from before, so term 0, 4 plus 3, that's what's going to give me my 7. So this actually is going to say, what you're going to write is, or if you already wrote something similar, that's totally fine, leave what you have. This is another way to show our function. A sub n minus 1 is known as the previous term. And the plus 3 tells me I'm adding or increasing by 3. All right. So I know this might be looking a little weird. You might be like, what the heck is this? But don't worry, we're going to go over it today. This is just an intro to it. So let's get started. So what you're going to do now is you're going to go into Desmos, students.desmos.com, and you're going to see in your group or class sequence card sort. So go ahead and open it. What I'd like for you to do here is what you're going to do, it says sort these cards according to similarities that you notice. What you notice about these pictures, about these functions, about these subsets, everything. So I want you to take a good 5 minutes and I want you to think about and sort however you want. So when you click the next button, I want you to convince me. Explain why you sorted these cards the way you did. And if you're like, oh wait, how did I sort them? You can definitely hit the back arrow and see how you sorted them. So take another 30 seconds and fill out this part. So go ahead and click the next button. Now it's asking you to sort them in a different, similar way. So since you sorted it one way, what you're going to do now, again, is sort it in a completely new and different way. Now this might be a little bit challenging, but remember, I want you to sort it how you think it should be. So take 30 seconds and go ahead and do. So now that you've sorted it a completely new way, I want you to again convince me why you chose to sort it this different way. So go ahead, take 30 seconds to answer this question and click the next button. Now that you've clicked the next button, I'm going to zoom in here and I want you to look at how Julie sorted her cards. So Julie sorted these cards into this certain pile. What method of sorting do you think that she used? So take a second, pause the video, and see what she sorted by. So one thing that I can notice is visually, she sorted all of the pictures together. She also put all of the A subset n's together, because look, all of these have subset n. They're just like, hey, choose whatever number you want, plug it in. While these ones actually give me, hey, A subset 1 is 3, boom, go ahead and figure it out. So go ahead and comment what you think, again, how she sorted it. And now we're going to look at a different person's sorting. So Matt sorted these cards into these types of piles. Let me zoom in for you and I'll show you. This is his first pile of 7 cards right here. And this is his second set. So here's his second set of cards. As you can see here, I'll zoom in for a second and see what he kind of sorted by, maybe. All right. So now that I've zoomed in on these methods, I want you to answer, what method of sorting do you think he used? And remember, there's no wrong answer. We're just learning about different ways people sorted. So now that you've taken a second, here's the thing. Matt sorted these actually by arithmetic and geometric sequences. Can you tell the difference now that I've mentioned that? Can you tell which is which? Absolutely. You can definitely tell that these 7 cards right here are 100% arithmetic. See how in the picture here I started with 5 and then I added 4 more and then 4 more to that. And even up with the A subset, we can see that it tells us what the first term is. So I could plug in 1 here plus 2. That should give me my second term, and so on and so forth. Even down here, these are similar equations, right, that we've been dealing with. I originally started with 1 block, and each time I'm increasing by 4 blocks, and so on and so forth. While his 9 category over here of cards, as you can see, this one is similar to the triangle problem you had the other day. I started with 1 blocks. It doubled, to 5 blocks, and then that doubled again to 5, 10, 15, 20, 25. So each time this is multiplying by 5. Same thing up here, multiplying by 4, multiply by 4. These A subsets also as well are geometric. We're multiplying or dividing or have an exponent. Okay, so if you want to rephrase yours, perfectly fine. If not, that's fine too. So last thing you're going to do is one more time sort them. But in this case, you're going to sort them into 5 different groups that show the same pattern in different representations. Now that you've done that, let's go review some vocab that we learned today. So today we looked at 2 different types of sequences, explicit and recursive. Explicit functions were given just the formula that allows us to simply plug in the term we're trying to find. So these can be, of course, arithmetic or geometric. They look something similar to this. They have A subset n equals something. These are explicit functions. While recursive functions are given, we're given the first term of the sequence and the pattern rule to get any term in the sequence. So we will always be, for a recursive, we'll always be given the first term and an equation. First term and an equation. Those are the 2 big differences between our arithmetic and geometric sequences. So now that you've known this, or know this now, you're going to go past your patterns and sequence PFA. Have a great day, guys. You've been doing awesome this year. I'm so proud.